Moving on to communicating with our devices. We use UART-driven interrupt to perform communication. When a character arrives, it would be stored in a buffer, which then would execute a callback function when the buffer is full. To make the device parses our command easily and simply, we design the buffer by assigning a number for a function and device parameters separated by delimiters. This is the structure of our buffer. When the buffer starts with a number, the buffer would be parsed to set the parameter to the device. For example, when we want to do cyclic voltammetry, we want to set the initial, final voltage, and its scan rate. This is where we set the parameters. On the other hand, when the buffer starts with a delimiter and a number, it would be parsed to do certain tasks, such as start the measurement, check the voltage, and so on. The callback function would not be invoked if the buffer is not full. Therefore, we make double delimiter add the end as the condition to manually invoke the callback function. This is our UART interrupt handling code. The incoming data is stored in a buffer and would execute the callback function when it's full. However, we also add another condition to execute the callback function so that we don't have to wait for the buffer to be full first. The callback function would check if there's any incorrect data in the first entry of the buffer. If everything is okay, it would change the state that the data transfer is complete. The loop that we previously mentioned would check if the transfer is completed. If it's complete, it would execute the handling function that parsed the data and execute the command or store it to the memory.